Have you ever wondered how geologists find valuable minerals hidden deep within the earth? It's not just about luck or digging randomly. One of the most powerful tools they use is geochemistry, which essentially acts as a chemical compass, guiding them to buried treasure. Today, we're diving into the profound significance of geochemistry in mineral exploration. So, what is it exactly? Geochemistry is the science of using chemical analysis of natural materials, like rocks, soil, and even water, to locate and define mineral deposits. This process is crucial at every single stage of exploration, from the first look at a vast landscape, all the way to estimating the size of a resource and planning for environmental safety. A key reason geochemistry is so important is that mineral deposits are often geochemical anomalies. This means they are areas with unusual concentrations of certain elements. When we find these anomalies, they point us directly toward potentially valuable resources. Exploration geochemistry focuses on finding these chemical signatures. Elements from a mineral deposit can spread into the surrounding environment, creating what's called a dispersion halo. By sampling the surface soil or water, geochemists can detect these halos and pinpoint a deposit that might be hundreds of meters underground. Sometimes, the main mineral we're looking for is hard to detect. This is where pathfinder elements come in. These are more mobile or common elements that are found in close association with the target ore. For example, when searching for platinum and palladium, geologists look for pathfinders like copper, nickel, and chromium. Their presence can form a much larger halo, making the hidden deposit easier to find. Different types of deposits also have unique chemical fingerprints. For instance, in certain sulfide deposits, high concentrations of the element thallium in pyrite can distinguish a rich ore zone from barren rock. Geochemistry can even help us find diamonds by targeting kimberlites. The soil above a kimberlite pipe, even a concealed one, will be noticeably enriched in elements like niobium, chromium, and magnesium, creating a clear target. Exploration is often most promising in areas with deep and complex weathering, but this also creates challenges. Geochemistry gives us the tools to understand these environments. Regolith geochemistry, which is the study of the weathered surface layer, helps us interpret how elements have moved around. This is vital for telling the difference between a true anomaly directly above an ore body and a false one created by the mechanical or chemical transport of elements over time. It also helps us understand supergene processes, where minerals are dissolved by weathering, transported, and then redeposited. This can create zones of enrichment, but sometimes the resulting anomaly is shifted sideways from the original source. Without a solid understanding of geochemistry, these situations could be easily misinterpreted. Modern geochemistry is incredibly powerful thanks to huge leaps in analytical technology. Advanced techniques like inductively coupled plasma mass spectrometry, or ICP-MS, allow for the fast, inexpensive, and highly precise measurement of trace elements at incredibly low concentrations. This level of detail is essential for solving complex geological puzzles. We can also use isotopes to unlock even more secrets. Radiogenic isotopes can reveal the source, age, and tectonic setting of the magmas that formed the mineral deposit. Stable isotopes, like those of oxygen and hydrogen, can trace the origin of the hydrothermal fluids that carried the metals, telling us if they came from magma, rainwater, or ancient seawater. Ultimately, geochemistry provides the solid data needed for strategic decision-making. In the early stages, it helps narrow down vast territories to the most promising provinces. As work progresses, higher density sampling leads to specific drill targets. All of this data forms the foundation for resource estimates and the feasibility reports that justify major investments. Beyond discovery, geochemistry is also critical for environmental management. It helps establish a natural chemical baseline before mining begins, which is used to monitor water quality and assess the risk of acid mine drainage from waste rock. This information is indispensable for planning effective remediation and ensuring responsible mine closure. In essence, from finding the first clue on the surface to ensuring a site is safe long after mining ends, geochemistry is the silent, powerful force that guides modern mineral exploration. It maps the invisible chemical world, revealing the history and location of the Earth's most valuable resources. Thanks for watching, and be sure to subscribe for more insights into our amazing planet.